Well, good morning. Good morning. My name is James Kimmery. I'm Director of Marketing at National Instruments. And I thought today I'd give you a little bit of background about NI if you don't know too much about NI. But I also want to talk about our role in wireless research and also about our support for the PAWR program and why we're very supportive of it. So first, I've been Director of Marketing for a while, but I actually wear a couple of different hats at NI. If you know me, it seems like when Tiago was speaking, I was thinking, I'm strangely attracted to very hard problems. And I know I do a lot of different things. But one of the things I do, I manage the SDR business. I also have a wireless research team. We worked on many different wireless projects, research projects, and I'll share some of those with you as well. But NI sells products and services to over 7,000 high-level academic institutions worldwide. So we have a pretty wide footprint. So I'm not going to talk too much about our products, but I am going to talk about our approach. And I think it's highly relevant to this audience. So a lot of you might know a few products that we have, but really our strategy is a platform approach. It's hardware and software working together. People ask me, they say, James, is NI a software company? Is it a hardware company? Well, actually, we're both. And to toot our own horn, I think we do both pretty well. But one of the things about a platform is it's extensible. And it's very important for a project like this. That means that if it's one engineer, one student working on a project that's well scoped, that's awesome. Maybe they use everything in NI, that's great. But if it's a project that's a citywide test bed or a campus-wide test bed, it probably is going to require a more heterogeneous approach, using a combination of perhaps other tools, technologies, hardware. And that's what's really exciting about PAWR. It is going to take a lot of mixing of different technologies, and we embrace that. I think you'll see in the next some of these examples that I'm here to share with you that a homogeneous approach really isn't going to work. We're going to have to learn to work together, not just as colleagues, but the tools, technologies are also going to have to work together as well. So let me share with you a couple of projects that we've been involved with. I think they'll be interesting for you. So this is a project with the city of Bristol and the university there. And this is actually, I don't know if I have the whole story right. And Mark Beach and Andy Nix probably give me a hard time. But the way that I understand it is that the city of Bristol actually discovered an underground fiber network. It was put there a few years ago, and either a company went bankrupt or whatever, but there was this fiber network underneath the city that was unused. And so the city officials went to the university and says, hey, what can we do with this? And so through, I guess, a series of collaborations, of course, and I was involved with a little bit of that, but they had this idea of creating this citywide network. And one of the goals that they wanted to have was to be able to have a mix of technologies, a mix of both spanning not just the base stations or access devices, but also the UEs, to use a technical term, a UE. So they had sensors, they have smartphones, they have commercial technologies, and they have a lot of experimental technologies as well. Very fascinating project. We've been working with them. And then what's interesting is they actually went from there to the UK government. They got funding, and now a good part of this is actually being deployed and successful. And I don't know if you followed what the researchers at Bristol, but the massive MIMO work that we've been a part of in terms of setting the spectral efficiency record was actually a part of this program. So this next project isn't necessarily a communications project, but I thought it was relevant for a lot of reasons, just because of the sheer scale. The scale of this project is immense. ISCAT is a group of researchers in well, actually, they're all over the world, but the leadership is located in Scandinavia. And this is a test bed with thousands of software-defined radios, collectively working as a single instrument to measure the ionosphere. Actually, specifically the Aurora Borealis, if I can say that correctly. So this is a project that actually was a dream. It was a dream many years ago, and it's just now being funded because the tools and technologies are now cost-effective and capable of being able to do this scope of work. We're very excited to be about part of this project, but one of the things that I also wanted to point out, they're using software-defined radios for this research, because when you have 10,000 nodes all networked together, both transmitters and receivers, they have to be able to be maintained efficiently. And that's maintained using commercial technologies over a network. So if some of the radios need to be reconfigured, they can do that from a central access point, and then they can be further enhanced over time as they get the experimental results. Very interesting. And then finally, I'd like to talk about the DARPA project, the Spectrum Challenge 2. I don't know if you've seen this one or not. This is actually a test bed plus a competition. That's always nice, isn't it? But I think there's $7 million in prize money. There was an original Spectrum Challenge that maybe some of you have participated in, and this one actually isn't over the air. It's using the world's largest channel emulator. It's a 256 channel emulator. And through the emulator, they can actually control the environment. And the environment they've nicknamed the Coliseum. You know, get this idea of this wireless gladiators doing battle. And that's really, that's the idea and the spirit, but they want to have a level playing field. And the way to make a level playing field is to actually do this all over in emulation. So the key point here is, again, the tools and technologies really weren't available to do this kind of work up until the last few years. And then, or at least cost effectively anyway. And then the capability and the scope of these are definitely high. The bar is high on each one of these projects, but you can see that they've made tremendous progress. So in closing, NI is very supportive of this initiative. You know, for you, those of you who know me, they know I like to talk about simulation. I mean, I think simulation is part of the process. It's an important part of the process, but it's not the end of the process. And taking that next step to get the students and researchers to go beyond simulation and actually build a prototype, and then build prototypes at the scale that we're talking about, is extremely important. I can tell you from, I just shared with you a few of the projects that we've worked on. The experience of the researchers and the students through this is really indescribable, because what they get out of it, what the industry gets out of it, I mean, we've learned a lot, and our tools and technologies have certainly evolved since we've been involved in these research projects. So with that, I wish you all good luck, and thank you.
Great. Next, I'd like to invite Rebecca Hunter up from Crown Castle.
Hi, good morning. I'm Rebecca Hunter. I'm with Crown Castle. I work in our corporate development and strategy group. We are very excited to be here and very excited to see all of the interested people here and potential proposers. So it's a very exciting day for us. Many people may not know who Crown Castle is, so briefly, just wanted to share a little bit about us. We are the largest shared telecommunications infrastructure provider in the U.S. That means towers, rooftops, small cells, and fiber. So that's kind of our specialty area, and we have a very deep asset base and personnel base throughout the United States. So why are we involved? Why is Crown Castle so committed to the board and to helping proposers with the PAWR program? I think it's very similar to why a lot of you are here today, and a lot of industry and cities and universities are coming together for this PAWR. One, we think the U.S. can be a leader and should be a leader in advanced wireless research. And through programs like PAWR, we think we can be. And so we're really excited to be part of that. We also think encouraging an open and scalable and innovative platform in order to be able to bring the collaboration that's needed to advance wireless research together. That's what PAWR stands for to us. In addition, we all know, I think, in this room that we see technology, wireless, as an engine of growth in the U.S. It's going to change dramatically our smart community aspects, public safety, economic development, how we interact socially. So it's really important that we see that PAWR is focusing on the commercialization and the real-world aspects of use cases and applications. So expanding beyond the idea of just research, which is fantastic, but also taking that to the next level and bringing it out to commercial use. And so how does Crown, why are we participating? Because we think we can bring value. We believe we have a unique position on the board and within our industry space to help proposers understand infrastructure. The basis for the foundation of all wireless networks, you have to have infrastructure. You need the small cells, you need the fiber, you need to understand how do you build and deploy a network. And so some of that for our experience is real estate, the permitting aspects of it, public utility regulation aspects of it, and the construction of networks. And so we highly encourage and really want to be a resource to help you understand, because that is probably one of the most impactful things to your time schedule and impactful things to your budget. So we just really want to encourage you as you're thinking about your innovative ideas and your research ideas, if you're going to be including any type of new wireless network deployment, small cell deployments, to really make sure you understand your local communities and your local municipalities and how you can work together to come up with a plan to truly employ that and really get those research projects out there through the network cases. So Crown Castle currently has a great example of how we currently collaborate on a project just like PAWR. We started about 18 months ago coordinating with Carnegie Mellon. I think if you're local to Pittsburgh, they say Carnegie Mellon, so I apologize. And with the Open Edge Computing Initiative. So this is very similar, and we really think it can be a great example and lead into exactly what the PAWR objectives are. So this is a consortium and a partnership and a true collaboration between the university, the Open Edge Computing Initiative, and Deutsche Telekom and some others, Nokia. You can see the members at the bottom. One really key element that I did unfortunately leave out of that partnership is the city of Pittsburgh. Because again, you have to have that city-university partnership to deploy that network, to have the commitment of those local resources in order to fully, receive the benefits of the network and the research you're trying to accomplish. So we also, on this network, it's focused on mobile edge computing at this time, but the idea is to bring in researchers to really share this information and to show use cases, commercialize use cases, retail use cases. So if there's any way that we can leverage our experience with the LEL, the Living Edge Lab, and some of our really in-depth resources that can help proposers understand network deployment implications, we're here to help. So with that, I appreciate your time, and we are very excited to be part of the PAWR board. Thank you so much.
So for our final presentation from industry consortium members, I'd like to invite Fred Schreider up from InterDigital to provide a third perspective.
This page down. Okay, very good. Okay. Good morning, everyone. I'm Fred Schreider from InterDigital, and I'm pleased to be here today with you and share our thoughts about who InterDigital is and why it's so important that we're involved in this PAWR program. So a little bit of background about InterDigital. We've been a pioneer in wireless development for 40 years. Way back in 1972, when we were founded, we were already looking at digital telephony way before the first 2G standard was even invented. We have deep history in the standards organization. We've contributed to 2G, 3G, 4G, and now working on 5G standardization. As you can see by the footprint, we are a U.S. company. We're headquartered in Delaware, and we have design centers in New York, where I'm from. Headquarters, as I mentioned, in Delaware. We have another one in Pennsylvania, an office in Montreal, an office in San Diego. And recently, 3, 4, 5 years ago, as part of the European Union Horizon 2020 projects, we opened an office in the UK. But now with them leaving, Brexit, we have to rethink where we're going to move from there. But we've actually had a lot of success with that office and getting some contracts through Horizon 2020. And we also have a small office in South Korea. And we've invested since 2000 $1 billion in research and development in wireless technologies and in networking. We are a licensing company. We don't make products, but we make technology that go into the cell phones that you're using and in the networks that are making those calls for you. So we're very proud of that, and we have a deep history in contributing to the standards. We have people actively going to 3G PP today. We have people going to IEEE 802.11, IETF, and ETSI. So right now we're focusing our 5G initiatives on something we call the living network. We believe the network is sort of a self-healing, self-organizing network that delivers services and content to you no matter where you are, where your location is, or whatever you want to do. And we are investing heavily on this right now. Oops. Sorry. Doesn't seem to be advancing for me here. Sorry about that. We'll go with this mode? Yes. Okay. It hasn't popped up yet. Thank you. Should I proceed? Okay, I guess I'll proceed and maybe we can figure out what's going on. So one of the test beds that we're currently involved with And we're pretty excited to present to you guys today because we think it might be applicable to what you're doing with the Smart Cities initiative, is our millimeter wave testbed that we deployed as part of a European Union project called 5G Crosshaul. And this is 60 millimeter wave links, which you can see here as we've deployed them on 3 rooftops in Berlin as part of this testbed initiative. And each of those links is about a gigabit, very low latency, less than a millisecond, sub-millisecond. And it's connected together through an SDN-based controller. So this is very software programmable, and the SDN controller is an off-the-shelf open source controller that we modified very specifically to handle what we call in-band signaling. So we can bring up this network, control it, maintain it, choose alternate paths. When links break, we can also provision new links, all through a centralized control that could be in the cloud, it could be anywhere. And we've used the basic frameworks that are out there today from the open source community to make these modifications to what typically is a wired-based SDN controller. So this, in this particular test bench, we had 3 nodes. One of them, the longest one was 185 meters, and we were actually showing here combining front haul and back haul traffic on these links. One of the initiatives or one of the goals of 5G Crosshaul is to actually unify front haul and back haul into a heterogeneous network. Right now, with 4G front haul, you've got point-to-point fiber optic CPRI links. And what this project aims to do is combine the front haul links in a packetized fashion along with your backhaul traffic. And we actually demonstrated a 3G test beds, or 3G, I'm sorry, eNode B, as well as one of the partners, Core Network Dynamics, was creating a 5G split, protocol split, and so that was an PLCP split that we were sending front haul traffic on this link, and that was very successful. So we think this has some applicability to what you guys are looking to. We'll be happy to talk to you offline today on this. And again, it's not working. So maybe what I'll just do and wrap up. Yeah, I'll just finish up. So again, we're very happy to be part of the PAWR program office. InterDigital is a founding member, so we are contributing in-kind contributions. This test bed is one of them, and we look forward to discussing any opportunities that you may have. Thank you.